Okay, friends, let's do one more video. It's going to be way less heady than that last one was. If that last one made your head spin, don't worry. This is where we actually use the negative numbers to do something. A lot of this stuff is based on something called expected value, which your lab will be about, and we'll chat about that soon enough. So we're going to evaluate this expression. So we're going to combine multiplication and addition, which means we have to use order of operations. Feel free to use technology for this. So 5 times -1 plus 6 times 1. Now, one way you can do it is multiplication first. 5 times -1 is -5. 6 times 1 is 6. And then -5 plus 6 is 1. Totally fine. You can also go to Google and type 5 times -1 plus 6 times 1. And it's going to tell you it's equal to 1. So by all means, feel free to use technology. All right, so this one down here, another Math 105 type problem. 0.5071 times -1 plus 0.4929 times +1. It looks similar to this one up here, except I've put some decimals out front. And believe it or not, this has to do with the game of craps. So we're going to go right back here because Google doesn't care about that. 0.5071 times -1 times 0.4929 times +1, and we come up with a negative 0.0142. And then the exact same problem, except the -1 and the +1, they're going to have units, dollars. So this is -$1, indicating a loss of $1, and this is +$1, indicating a gain of $1. So I'm going to stick a dollar sign right in front of those, and Google is smart enough to figure out what that is. And press enter, and it tells you that could look familiar, negative 0.0142 US dollars, which is exactly the average quote-unquote winnings in a game of craps. We'll talk more about that in Math 105. The important thing right now is making sure that you can actually evaluate this kind of expression. And again, I mentioned that down here. Just to give you a little bit of a backstory on these numbers here are probabilities. They're the chance of something happening. And these dollar amounts are the payouts that something happened. 0.003 times $109. I'm going to start with that. All right. And when all is said and done, that's going to equate to a positive 18.6 cents or 0.186 US dollars. So that's positive. What I wanted you to compare and contrast that with was same probabilities, but then your first 3 payouts are different. That one's not 109, it's 54. That one's not 9, it's 4. And that one's not 1, it's 0. So let's change those in our Google window. And we end up with negative 40.7 cents, about negative 41 cents. Now what's incredible is, in the previous one was a positive 18.6 cents, and this is a negative 40.7 cents. And I don't want to say too much more about this because this is what we're getting into in our lab with negative numbers, which is honestly the most important application for you as a pre-stat student. But the idea of this, and if you read down under this question, is the difference between the positive and negative meant $250,000 for a couple students who caught the math mistake that was left by the New York Lottery Commission with this one particular lottery game. If anybody's interested more in that, I can give you the backstory on it. It's pretty awesome. Every once in a while, the Lottery Commission screw up and leave a gift waiting for those who are lucky enough to catch it. I have not caught it yet. And the one last question is down here. I'm going to let you stew on that one. Think about it. If you got questions, drop in the meeting. Let's give the homework a shot, and then we'll do our expected value lab. Talk soon.